Pedal Systems is one of the leading companies in India which is engaged in UAV design and manufacturing. It also focuses on many UAV domains such as UAV training, GIS survey, aerial survey, and design services. Pedal Systems is offering you this course, Basics of Flight. To know more about us, visit our website or feel free to write us to the following mail ID. We will start with the index. We will see what all are contents for this course. So first we will start with domain of aeronautical engineering. We will discuss various domains, various branches of aeronautical engineering and their sub branches. Then we will discuss various parts of aircraft. So what all parts of an aircraft are present and what are their functions. We will discuss each of them in detail. Then we will see classification of aircraft. We will see various kinds of aircraft based on different configurations. Then we will see forces acting on aircraft, what all forces act on an aircraft and what all are resultant motions of the aircraft. So we will see both of them. At last we will see different mission profiles of aircraft based on their applications. So different kinds of aircrafts will have different kind of mission profiles. So we will discuss each of them in detail. So we'll see all these contents step by step in the following slides. So let's see what we will expect from this course. So after dealing with this course, one will be able to understand an overall idea about the field of aeronautical engineering, the vast domain of aeronautical engineering, the branches and their sub branches. So one will be able to differentiate and group the several branches which are present of aeronautical engineering, then various parts of an aircraft with their applications during the flight. So the functions of the different parts of aircraft and where they are attached, then classification of aircrafts based on various configurations available, then four forces which act on an aircraft, which includes all of the aerodynamics. So these forces which act or which are the product, these all come under aerodynamics. So we will see these as well. Then the three basic motions of aircrafts which are helpful during the flight. Then variety of mission profiles of aircrafts based on their application. So after dealing with this course, you will have a complete idea about basics of any flight for any aircraft. So let's begin the course. So first we will start with domain of aeronautical engineering. So we will see that aeronautical engineering mainly has four branches. The first branch is aircraft structures, then it is aircraft propulsion, then it is aerodynamics, and the last one that is avionics. Though these are the main primary four branches of aeronautical engineering, there are several other branches which comes under these branches. So these are the main four domain we can say. So in aircraft structures, it is completely about the structure, the stress and strain acting on the aircraft, the body, the materials, the strength. These all subjects come under aircraft structures. Then we have aircraft propulsion. So propulsion means the thrust which is created to move the aircraft forward. This thrust is generated by the engine. So propulsion here mainly deals with the engine part. Then we have aerodynamics. Aerodynamics is study of air moving around a fluid. So how lift is generated, how an airplane can fly, can take off and can land and perform various operations in midair. So these all study comes under aerodynamics, and then it is the avionics part. The avionics mainly the controls which the pilot has to move the aircraft or to carry out these all operations. So these all comes under avionics. So under structures, we have various categories that is finite element analysis, aircraft materials, aeroelasticity, fracture mechanics, composite structures, fatigue and fracture. So in finite element analysis, we carry out different computer aided simulations using finite element method to understand the behavior of the structure when several loads are applied. Then it is aircraft materials. So what all kind of materials will be useful to build an aircraft or what all materials are used for different parts of an aircraft. Then it is aeroelasticity. So we know the flutter phenomenon. So aeroelasticity includes flutter, divergence, these all phenomenon that when the aircraft will fail. Then it is fracture mechanics. Then we have composite structures. Mainly nowadays the aircrafts they are made of composite structures which are very advantageous compared to standard metals like aluminium. Then we have fatigue and fracture. These are the sub branches under aircraft structures. So aircraft structures include all this topic which will help to understand the structure of an aircraft very well. Then it comes to aircraft propulsion. So propulsion deals with the engine. In aircraft propulsion, we have turbo machinery, then innovative gas turbine cycles, then we have propeller design, heat transfer, combustion, computational fluid dynamics, gas dynamics, and thermal acoustics. So in turbo machinery, as we know that aircraft engine has various parts like compressor, turbine, combustion chamber, etc. So turbo machinery is one of the part that deals with designing of such components for engine. Then it is innovative gas turbine cycles, that is with less fuel, how we can improve the efficiency of the engine, a better gas turbine cycles. Then it is propeller design. So some of the engines they have this propeller around it. So even designing that propeller is a vast study one can explore. Then it is heat transfer. As we know, as an engine, heat will be produced. So there will be heat transfer from one segment to another segment. So these all studies. Then the combustion phenomenon which is there. So even combustion has various subcategories under it, that is spray, ignition, etc. Then it is computational fluid dynamics. Here we carry out simulations for the engine based on different problems. So we will get to know the results early before the engine is made. Then we have gas dynamics. In gas dynamics, we study the fluid. It may be fluid properties or the relations, etc. In thermal acoustics, we mainly study about how we can reduce the thermal noise which is created because of an aircraft. So these all categories come under aircraft propulsion. Then we have aerodynamics. So aerodynamics, it has general aerodynamics, subsonic, transonic, supersonic, hypersonic, wind tunnel testing, flight mechanics, computational aerodynamics, stability and control. So general aerodynamics will include study of what all forces are generated, what all movements are generated, how we can control these forces, what motions are created because of aerodynamics, etc. Subsonic aerodynamics is mostly equal to general aerodynamics. Then we have transonic aerodynamics. Transonic aerodynamics is the study when the aircraft reaches nearly Mach equals to 1. Then it is supersonic aerodynamics where the aircraft is moving at Mach numbers higher than 1. So that is very complex, so shock waves and everything is involved. And hypersonic is even more far than that. That is when the aircraft crosses Mach 5, it goes into hypersonic region. So study of these regions is under hypersonic aerodynamics. Then we have wind tunnel testing. So before creating a prototype, small wing aerofoil geometries are created and they are placed into wind tunnels, and the flying conditions are created in the wind tunnel itself. So the flow will be coming, and then one can visualize the flow behavior or the airfoil behavior based on the flow condition. Then it is flight mechanics, that how an aircraft can take a turn, how it can pitch down, how it can land on a runway. So these all is included into flight mechanics. Then it is computational aerodynamics. So earlier how we have seen finite element analysis and computational fluid dynamics, just like that we have computational aerodynamics where we can carry out simulations and we can reduce the wind tunnel testing cost here. Then we have stability and control. So in stability and control, mostly it involves how we can make our aircraft more stable with less complexity. So these all are the sub branches for aerodynamics. Then we will move on to the last, that is avionics. So avionics, it consists flight controls, navigation, engine controls. So mostly the electronics part, that is the devices which control all of these movements of an aircraft, is included under avionics. So this is the complete domain of aeronautical engineering, and these four are the specializations which have many other subcategories. Most of them I have mentioned here. Then we will go to the next topic, that is we will see different parts of an aircraft. So some of the major aircraft parts are listed here. So here we can see to the left we have different parts as a list, and next and right we can see a figure where these parts are mentioned at the locations of an aircraft and their functions are written. So we will discuss each of them in detail. So let's start with the fuselage. So fuselage is the body of the airplane that all the parts are attached to. So the main body to which the wings, the engine, the landing gear, the tail, empennage, everything is attached. The main body is called as fuselage, and it can be made of many different substances such as aluminium or wood. The modern aircrafts which we see today, they are mostly made of aluminium, the standard aluminium, and then now we are seeing some aircrafts which are made of composites. So this fuselage is the main body in which the passenger sits, the body which carries the payload. So next part, that is wings. So wing is the most important part because it creates the lift. Because of this wing, an airplane can fly. The part of the plane that creates lift and controls roll. So the rolling motion is even controlled by the wings, and even lift is created with the help of these wings. has a rounded leading edge and tapered trailing edge which helps create lift. So this geometry of an aircraft helps in creating lift. If we take a cut section of the wing, we can see it is a 2D aerofoil which creates the lift. Then we will see for ailerons. So ailerons are located at the top of the trailing edge of the wings which controls roll, move up and down to control the direction of wind blowing over and under it. So these are located at the trailing edges of the wings and they help the aircraft to roll during the flight. Then we will see flaps. So flaps are located near at the trailing edge of the wing near the fuselage. The flaps help to increase the lift during the takeoff. So during flights, we have seen that while taking off, a wing-like structure is attached to the trailing edge, a small part. It will go up and down during the takeoff and landing. So this part is called flap, which helps to increase the lift along with the wing. So flaps are also called as lift augmenting devices. Next we will see rudder. So rudder provides side to side control of an airplane that is called as yaw and it is used for maneuvers in the air and for taxiing on runway. So this is vertical tail we can say. So the side by side movement of this rudder which will help to control the yaw motion during the flight. Also it is used for some of the maneuvers and on runway we can see with the help of rudder, aircrafts are taxied or they are parked at a certain location. When they have to move from one location to another or they have to take a turn, they will use this rudder on the ground to move the aircraft in a certain direction. Then we have vertical stabilizer. So vertical stabilizer is vertical to the horizontal stabilizer. It helps to airplane maintain level flight. So this vertical stabilizer has the rudder attached to it. Then we will see horizontal stabilizer. So it is horizontal with the fuselage, helps airplane maintain level flight. So this is located at the end part of the fuselage where the elevators are attached. So mostly this horizontal and vertical stabilizer, it makes the complete tail which we call as empennage. Then we have elevator. So just discussed elevators in line with the behind the horizontal stabilizer which controls up and down movement of aircraft which is called as pitch. So this up and down movement of this elevator will help aircraft to move up or down. This motion is called as pitch. Then we have the next part that is propeller. So this propeller uses the principle of a wing to create thrust to move the airplane forward. So same like wing, propeller uses principle of wing to create thrust. It can have different number of blades or we can say propeller. Design is similar to an aerofoil. So it just looks like an aerofoil but it has a small twist near the root. So this helps in maintaining a proper flow near the nose of an aircraft. Then we have engine. So engine helps the propeller to run at high RPMs to increase the thrust. So propellers are attached to the front part of the engine and engines are used to rotate this propeller at higher RPMs which will create thrust. Also jet engines generate thrust to make aircraft move forward. So there are some other categories of engines as well, that is turboprop, turbojet. So these different engines will help create thrust for an aircraft. Then we have next part that is engine cowling, a cover to protect the engine and make the plane more aerodynamic. So we cannot just keep our engine open like that in the environment. It will damage some of the parts due to friction. So we have a covering which will be an advantage in aerodynamic way. It is a smooth covering for an engine where flow will be maintained smooth near the surface. Then we have cockpit. So cockpit is the place where the pilot controls the airplane. The airplane control gauges and indicators are held here. So the front part of an aircraft, the nose part where we can see small windows, is the place we call as cockpit where the pilot sits and it controls the entire movement of an aircraft. The next part we have is landing gear. So a frame with wheels that allow the plane to take off and land. Some airplanes have retractable landing gear. So landing gears are mostly like wheels for an aircraft which will help to move during the takeoff and during landing. So in midair the landing gears are taken up. So these kind of landing gears are called as retractable landing gears. There are even fixed landing gears for some of the small aircraft. Then we have next part that is nose gear, the front landing gear when the plane has three wheels to land. So nose landing gear is the front landing gear. So when an aircraft is landing, we can see that first the back wheels will be the back landing gears will be landed on the ground and then the entire weight of the aircraft will be stressed to the nose landing gear. So nose landing gear is one of the important component when an aircraft is landing. Then we have spinner, so a pointed cone available attached to the propeller to reduce air drag. So a spinner is mostly used for turboprop engines where the propeller is attached to it, which will help in reducing the drag. Then we have winglet. So winglet is a wingtip device used to reduce drag. So mostly we have seen today's planes, they have winglets attached to their wingtips. So it is nearly vertical aerofoil at an airplane's wingtip. So this will help reduce the drag for an aircraft. So till now we have seen different parts of an aircraft. So now we will see what are different forces acting on an aircraft. So different forces which act on an aircraft we can see clearly in this image. That is, thrust is in the forward direction for an aircraft, drag is in the reverse direction. So these two forces are opposite to each other. Then we have lift, which is moving upward, and the weight, which is moving down. So these are the four forces which act on an aircraft, the major four forces which are responsible for a flight to take off, to fly midair, and to land back to ground. So lift is nothing but it's an aerodynamic force created by the effects of airflow past the wing. So using Bernoulli's principle, lift is generated when the airflow is passed through the wing and the airplane is lifted. Then we have weight. So weight is the self-weight of an aircraft which acts downward due to gravity. So gravity will always be acting on an aircraft. So the aircraft has to reverse this gravity and it has to be lifted. So lift and weight will always act opposite to each other, and when the lift will be more than the weight, it will take off. Then we have drag. So drag is an aerodynamic force which resists forward motion. Then we have thrust. So thrust is a forward acting force generated by the power plant which opposes the drag. So this thrust is created with the help of an engine because just lift will lift the aircraft in upward direction, but it has to move forward to carry out an operation, to carry out a mission, provide a service of transportation for passengers. So the aircraft has to move forward, and engine helps in creating this thrust which is needed to move the aircraft in forward direction. So drag is the force which is created due to aerodynamics, which is opposite for this thrust. So it will act in backward direction, which resists the forward motion of an aircraft. So next we will see motions of aircraft. So there are three basic motions of an aircraft which are yaw, pitch and roll. So yaw is side to side movement. So in figure to right we can see the middle part where we can see an aircraft is yawing, that is it is taking a slight turn to the right. Then we have pitch. Pitch is an up and down movement. So this pitching movement will help aircraft to maintain a level flight at a particular altitude. Then we have roll, that is rolling motion, that is one side of a wing will be at a different angle. Then in the middle figure we can see that these are the different axes, and these all axes meet at a single location, that is CG of an aircraft. We will see how these motions are created with help of these devices. So in first figure we can see yawing motion using rudder. So here we can see the rudder part which is present at the empennage at vertical stabilizer. The rudder is moving in side by side direction, and how the aircraft is moving in side by side direction with the help of rudder. So rudder helps in yawing motion. Then we have pitching motion using an elevator. So the elevators which are present at horizontal stabilizer and the empennage part, we can see how the elevators are moving up and down and how it is affecting the aircraft to move up and down. Then the last motion, that is rolling motion using an aileron. So we can see one aileron is moving up, the opposite aileron is moving down, and this is helping the aircraft to roll at a particular axis. So these are the three basic motions of an aircraft which are used midair to carry out certain operations. These motions are generally because of the flow behavior. The movement of these parts of an aircraft will create different airflow distributions around the aircraft body, which will help it to move in certain direction. That is, it will create different motions. So we have discussed motions of an aircraft. Now we will see different types of aircraft. So types of aircraft can be categorized using conventional configuration, unconventional and special issue configuration. So under conventional configuration, we even have different types based on power plant location, intake location, wing vertical location and tail unit arrangement. So these are the conventional configurations which we will see every time. But again they vary based on where the power plant is located, how is the intake located, then how is the wing vertical location placed for the aircraft, and how the tails are located for this conventional configuration. Then we have unconventional configuration, which we see rarely, that is biplanes. Then variable sweep configurations, canard configurations, blended wing body configurations. Then we have special issue configurations. So these category involves different kind of airplanes which are made for some particular objective. So these are short takeoff aircrafts, vertical landing aircrafts, then stealth technology aircrafts. So we'll see each of these categories and their subcategories in detail. So for conventional aircraft, as we have seen, we have power plant location. So the power plant may be located at the nose, outer wing, over wing, in wing, rear fuselage, internally housed. So these are the different locations at which the power plant can be located. Then we have intake locations. So this intake can be placed at the nose, side, chin or dorsal of an aircraft. Then we have wing vertical locations. So even these vary. That is, the wing may be high wing, mid wing, low wing, dihedral, anhedral, gull, inverted gull. So we'll see each of these categories in detail in further slides. And the last one, that is tail unit arrangements, that is variable incidence tail, then T-tail, multi-filled and butterfly. So these are the subcategories for conventional configurations under 4 different subcategories. So we will see some of these in details. So now we will see the first category, that is under conventional configuration. We will see power plant location. So based on the power plant, the engine where it is located, we can classify our aircrafts in conventional configuration. So nose mounted configuration is the first one, where we can see the engine is placed at the nose of the fuselage, that is the first front location of an aircraft. So nose mounted configuration gives symmetry of layout. Then it provides good clearance for propeller. So if we are using a turboprop engine at the front of an aircraft, then it will provide a good clearance for the propeller. Then we have outer wing mounted configuration. So outer wing provides beneficial wing bending relief, and pods in front of wing helps avoid flutter. So we can see that engines are mounted at the bottom of the wing and they are placed very ahead of the leading edge. So this will avoid the damage to the wing and also to the engine. Then we have in-wing mounted configuration. So in in-wing mounted configuration, the wing and the engine both are placed in one single structure. So this is very dangerous kind of configuration, because if a wing starts to stall, then it will damage the engine and it can work vice versa also. Also, the stresses generated because of the vibration of the compressor and turbine inside engine can cause harm to the wing, which may give a stall. Then we have internally housed engine configuration. So the configurations in which engines are placed inside the fuselage body itself. So these kind of aircrafts comes under the category of internally housed engines. So this kind of configurations helps in minimizing the radar cross section, obviously because the engine is getting consumed inside the fuselage body itself. Radar cross section which will be eventually reduced. Generally this kind of configuration is used for military transport, bombers and tankers. So nowadays we see such kind of engines for fighter jets in which the engines are mounted inside the fuselage body itself. While the nose mounted configuration and in-wing mounted configurations are rarely seen, this kind of configurations were used in olden days where technology were not yet evolved, whereas the outer wing mounted configuration we see today a lot in civil transport aircraft. Next, other we have two categories more under this, that is over wing mounted configuration. So here we can see the engines are mounted over the wing. Even the wing is placed at the top of the fuselage and then engines are attached. So this placement uses the Kondo effect and it provides lower minimum flight speed. So it decreases the length of runway needed for takeoff and landing. So this may be the advantage for such kind of configuration, but the problem here is very complex because the engines are placed, and if something goes wrong with the engine, then it can damage the whole fuselage body along with the wing. Then we have rear fuselage body configuration. So engines are placed at the back or the rear of the fuselage. They are connected with the fuselage body itself. So this kind of configuration receives good airflow, and also it is distant from the ground to avoid any foreign object damage, and also it does not occupy any fuselage space. So such kind of aircrafts were seen earlier where engines were podded in the rear fuselage section. Then we will see for the next category, that is intake location under conventional configuration. So where the intake or where the intake for an engine is placed, based on that we can classify our aircraft. That is, first the nose intakes, So the nose intake, where the engine is placed at the nose, so the intake will also be placed at the nose. So it were used for first generation and second generation aircrafts which had smaller bodies. It provides straight lined duct flow to engine. But placing a radar in forwardmost position is more advantageous than placing an air intake. So if we place an air intake at the very nose of the fuselage, we have to place our radar in any other location where it won't be good enough. But putting air intake at the nose of the aircraft will provide a straight line duct flow for engine, and it will be very advantageous, can help increase the efficiency of the engine. Then we have side intakes. So the engines which are internally housed will use this side intakes. The twin engine heavy fighters tend to use side by side intakes. In side intakes, flow has to turn twice to reach to the engine. This may lead to a turbulence problem which can starve the engine for air or turbulent air causing vibrations of the engine. So generally this kind of intakes are placed for twin engine heavy fighter aircraft. The air which is entering inside the engine, it has to turn twice while it is entering inside the combustion chamber directly. So this can cause a turbulence problem and it can starve the engine for air because there will be some losses because of the turning and twisting of the air inside. Then we have more two categories under this, that is chin intakes. So chin intakes are suitable for single engine aircraft. It get uninterrupted airflows regardless of the angle of the attack, helps to keep radar in the most forward position for an aircraft. So placing an intake at the bottom of the fuselage for a single engine aircraft is very advantageous because even the radar is placed at the front top of the fuselage and then intake is placed at the bottom, thus making the name as the chin intake is very advantageous for single engine aircraft. Then we have next is dorsal intakes. So with dorsal intakes, lower angle of attack and sustained turn is possible, but it is not suitable for highly maneuverable aircraft because as the angle of attack goes on increasing, engine gets less air. This is true because we can see that dorsal intake is placed on top of the fuselage but after the cone which is created cockpit. So when we are moving with higher angle of attacks, this intake will be masked or it will be covered with the cone of the cockpit and there will be less air for engine to take inside. So these are the four intake locations for aircraft and based on these intake locations, this kind of aircrafts are classified. Next category we will see is wing vertical location. So under wing vertical location, we have high wing configuration, then mid wing configuration, and low wing configuration. So these wings can be placed at the top of the fuselage, in the middle of the fuselage, or at the bottom of the fuselage. So based on that, it is classified as high wing, mid wing, and low wing. So for high wing airplanes which are very stable at slower speeds, meaning that they can right themselves quickly if they encounter turbulence while traveling slowly. So this kind of aircraft travel slow but are very useful in cargo transport. So heavy duty cargo transport aircraft generally have this high wing configurations because they are very stable at slower speeds. Then we have this mid-wing airplanes which are very well balanced and their design means that they have a large control surface area. As a mid-wing, the air will be completely distributed along the long surface area which is provided because of wings attached to the mid-surface which makes them more balanced. Then we have low wing airplanes which are more stable than mid wing airplanes but not as much as high wing airplanes. They are also more maneuverable than high wing airplanes. So low wing airplanes we generally see in our civil transport aircrafts because they are much stable than mid wing airplanes but not as much as high wing airplanes. Also these aircrafts can be used for good maneuvers. Then the next category here we have is wing vertical location, under which again we have dihedral, anhedral, gull, and inverted gull. So inverted gull wings exhibit the opposite stall behavior, but both normal and inverted gull wings impose lift to drag ratio and climb performance. So the gull wing we can see that there is a little bend in the wing and inverted gull is opposite to that. Then dihedral is where the wing slopes in a positive degree in relation to the wing base, whereas anhedral wings have a negative slope from the wing base. So you can see how the dihedral and anhedral wings are placed. So generally these wings are placed at lower part of the fuselage and they are more beneficial than anhedral wings. Then dihedral wings are used on large planes like commercial planes and anhedral wings are used on small military planes to control the roll stability. Then the next category we will see is tail unit configuration. So how the tail is placed and what all are the components of the tail, based on that we can classify it as: one is variable incidence configuration. So a horizontal stabilizer with a variable angle of incidence is placed. Then it might be used for trimming purposes only or for pitch control, and it is mostly controlled by pilot's input. Then we have T-tail configuration. In T-tail, we can see that the horizontal stabilizer is placed at the top of vertical stabilizer. The tail plane is often out of the distributed airflow behind the wing and fuselage, giving smoother airflow over the elevators, which reduces the drag. So this configuration can be used to reduce the drag. However, the aircraft may be prone to stall at higher angle of attacks when airflow over the tail plane and elevator is blanked by the wing. So to use this kind of configuration in fighter aircraft will be more dangerous, because fighter aircrafts, they travel at higher angle of attacks to perform the maneuver. Then next two aircrafts under tail unit configuration are multi-fin configuration. So the tail aircraft have two vertical stabilizers. Many modern combat aircrafts use this configuration. The twin rudder may be used in the gear down configuration for additional longitudinal control with tow in or flare out. Here we can see there are two sets of horizontal stabilizer and vertical stabilizer, which are placed in opposite direction at a diagonal axis at a 90-degree angle. This will provide additional longitudinal control with tow in and flare out. Then next we have butterfly configuration. So here we can see VTOL produces less induced drag and parasite drags because of less wetted surface area. So here the wetted surface area is very much reduced because of the absence of horizontal stabilizer. Then V-tailed aircrafts require longer rear fuselage than aircraft with conventional empennage to prevent yawing. So this kind of aircrafts, they require longer rear fuselage than aircraft with conventional empennage, which we are seeing till now, to prevent yawing. So this kind of configurations is mostly used in UAVs, that is unmanned aerial vehicles, and it is very difficult to use this kind of configuration in civil transport or fighter jets. Then next we will see unconventional configuration. So under unconventional configuration, we have categories of biplanes, blended wing body designs, canard designs, then variable sweep configurations. So under conventional, we have seen there was some kind of similarity in all those planes. But in unconventional configurations, we can see how these bodies are different than the bodies we have seen till now. So under biplanes, we have a biplane is a fixed wing aircraft with two main wings stocked one above the other, have greater advantage than a monoplane. So biplanes, the name itself says bi, that is two. So it has two wings which are placed parallel to each other at a certain distance. So the first flight which was flight, it was a biplane, and then it has evolved from two wings placed parallel to two wings placed side by side of a fuselage. So this is the evolution we have seen from biplanes to the conventional aircrafts which we see today. Then we have blended wing body designs, which gives us significant payload advantages, increased fuel efficiency, but then again we have a disadvantage that evacuating a blended wing body in an emergency could be a challenge. So we can see the design of this kind of aircraft, where this is a single body aircraft in which it has fuselage, it has wings, it has engines, everything is placed inside one single body. So such body provides excellent advantages for payload carrying, but again evacuating this kind of aircraft in an emergency will be very dangerous. Then we have canard designs. So it reduces the main wing loading and it allows better control for main wing. Then they allow better control for main wing flow because the canard wings are placed just before the main wings. Then we have variable sweep configuration. So this provides better aerodynamic efficiency of the aircraft at different flight speeds. It also has poor stability and complex actuator system. So the sweep angles, generally we see this kind of configurations in fighter jets where the wings are swept back or swept forward based on the application. Then we will see the next category, that is special issue configurations, under which first we have is short takeoff and landing. So such kind of aircrafts provide shorter distance to take off and land. That's why the name is short takeoff and landing aircraft. So these are very small configurations and are used for short range applications. Then we have vertical landing. This kind of aircrafts can hover, take off and land vertically without relying on a runway. So today we have some aircrafts which can land vertically and take off vertically without any runway. It includes variety of aircrafts like helicopters, gyrodynes, etc. Also Harrier is one of the example of vertical landing aircraft. Then we have stealth technology aircraft. So stealth aircrafts are designed to avoid detection using a variety of technologies that reduces reflection, emission of radar, infrared, visible lights, etc. So these kind of aircrafts are used for special missions where it cannot be detected by any radar or such kind of any variety of technologies like infrared, etc. So this kind of aircraft bodies are very different than the usual designs and are generally used for special missions only. Then next we will see mission profiles of an aircraft. So what is mission profile? Mission profile describes various flight segments of an aircraft mission. So we have an aircraft which will take off from a runway, it will fly and then it will land back on the runway. So this is one profile which we see, which we know till now. But there are various segments in this mission profiles. So we'll see what all are they. So first one is taxiing. So taxiing is movement of an aircraft on the ground under its own power. So before taking off, we see that the aircrafts are moved from one runway to another runway if any other aircrafts are trying to take off. So this movement of an aircraft on the ground is called as taxi. Also, after landing the aircraft is taken to park at a particular location. So this movement of aircraft on the ground is known as taxiing. Then takeoff is the action where aircraft leaves the ground and starts flying. So we all are familiar with the takeoff phenomenon. Then it is climb. So climb is an operation of increasing the altitude of an aircraft. So after taking off, we have this climb where we have to climb at a higher altitude where we can continue our flight. So next is cruise. Cruise is very stable flight segment of any mission profile because it is a flight phase that occurs when the aircraft levels after a climb to set an altitude and before it begins to descend. So most of the time of an airplane is in the cruise flight condition only because after taking off and climbing at a certain altitude, the aircraft has to travel straight at one single altitude to cover the distance. So this phase of flight segment is called as cruise. Then we have descent. Any time period during air travel when an aircraft decreases its altitude. So whenever the aircraft is trying to prepare for the landing, it starts to descend. That is, it starts to reduce the altitude so that it reaches the ground. Then we have maneuver. Tactical movements performed by fighter aircrafts mid-air is called as maneuver. So we see many fighter aircrafts, they are performing spinning, they are performing some rolling action. So these all comes under maneuver. Then again we have some other flight segments, that is refuel. So refuel is process of transferring aviation fuel from one military aircraft, which is called as tanker, to the another, that is the receiver, during flight. So the tanker aircraft will carry the aviation fuel in mid-air to reach to the receiver aircraft which needs the fuel, and then with the help of tube and hose configuration, the aviation fuel will be transferred from the tanker to the receiver. Then we have the loiter. So loiter is a phase of flight consisting of flying over some small region. So often there happens that the runway is busy and the pilots are advised to wait. So in that wait period, the pilots used to loiter around some small region, that is they just wait to get landing permission on a particular runway. So they fly around a small region. So this process is called as loiter. Then we have the landing, that is last part of a flight where an aircraft returns to the ground. So the aircraft has performed several activities and now after the descent and the loiter phase, it is coming back to the ground, that is it is landing to the ground. So these are the flight segments, complete flight segments of for any mission profile. So we'll see each of these and we will see mission profiles for different kinds of aircrafts as well. So first one we will see for simple cruise mission, that is for civil aircraft. So this is typical mission for many transport and general aviation design, including the home build. So first it will take off, then it will climb, then it will cruise at a certain altitude, then it will start to descend, then it will loiter at some particular small region, then it will land back. So this is typical mission for many transport and general aviation designs which we see today. So for safety, reserve fuel or extra range or loiter, 30 minutes is added in this flight phase. So aircraft is mainly sized for cruise range. So most of these aircrafts are designed for such kind of mission profiles. Then we have air superiority mission, that is for military. So here we can see this mission profile is very different than the first one. So this includes cruise, then combat segments consisting of certain number of turns, weapon drop, cruise back and loiter. The second segment is identical to the first segment. So this mainly is the mission profile for military aircrafts where it will take off, then it will climb, it will cruise, then it will perform some combat segments That is, it may loiter or it may weapon drop the weapons at a certain location, and then it will start to climb. It will cruise at a certain altitude, and then it will loiter back and land back to the ground. So this weapon drop segment may include firing guns or firing missiles. So the next category is low level strike mission. This is again for the military. This includes dash segment at weapon drop segment flown at just a few hundred feet of the ground for improved survivability of the aircraft as it approaches the target. Then we have next one, that is strategic bombing mission. This is mainly for military. So after initial cruise, a refueling segment occurs. The R, which is present in the mission profile, is required for achieving long range. Return cruise will be far shorter than the outbound range and will land sometimes at bases in friendly countries for refueling after completing of a mission. So this strategic bombing mission, which is used for military jets, is a very long mission profile which will include takeoff, it has climb, then it has to cruise, then even if the mission is not completed, it has to refuel. So refueling process will be done mid-air, then it will cruise, then it will descend to some certain location, then it will loiter at some location, then it may drop some weapons, or again it may refuel by landing back to the ground in friendly countries, and again it may take off back, and then it may loiter, and then it may return back to the ground. The last mission profile which today we will see is civil transport missions. So it is very common profile for all civil transport aircraft operating under FAA regulations. In addition to mission fuel requirement for contingency, aircraft must carry additional fuel as a reserve segment for the mission. Here we see it will taxi, then it will take off, initial climb, then climb, it will cruise to a certain location, then it will descend, then it will start approach to the land, then it will land, and then it will taxi. But again, if there happens that the approach to land is missed, then the aircraft will again start to climb, and then it will cruise, then descend back, then land back to the ground. So this may happen if there are some risky conditions like there is low visibility or there is high wind conditions. In these conditions, it may happen that the landing approach is missed by the pilot. So the pilot will climb the aircraft back to a certain altitude, and then it will cruise at certain altitude, and then it will approach back to the ground. So for this kind of purposes, regulations are made such that an aircraft should always carry a reserve fuel with them to tackle such kind of conditions. So these are the 5 different mission profiles for different kind of aircraft. So the summary for today's class we will see is that we have seen an overall idea about the field of aeronautical engineering domain. So we have discussed various branches and their sub branches, that is aerospace propulsion, aircraft structures, avionics and aerodynamics, and again their sub branches. Then we have seen various important parts of an aircraft with their application during the flight. So we have seen fuselage, wings, flaps, elevator, ailerons, and their functions during the flight. So these devices perform some operations which are very useful for an aircraft to fly. Then we have seen classification of aircrafts based on various configurations available. So we have seen conventional, we have seen unconventional, then special issue configurations. So under conventional, we have seen variety of aircrafts where they vary based on where the power plant is located, how the intake is placed, how the wing vertical location is placed. And then under unconventional, we have seen biplanes, blended wing body designs, canard configuration. Then in special issue configurations, we have discussed about stealth technology aircraft, short takeoff and landing aircraft, vertical landing aircrafts, etc. So variety of aircrafts and variety of configurations we have seen under classification. Then we have seen 4 forces acting on aircraft, which includes all of the aerodynamics. So we have seen what is lift, drag, weight and thrust, and how these forces act opposed to each other, and how these forces are important for an aircraft to be airborne. Then we have seen the 3 basic motions of aircraft which are helpful during the flight. So we have seen the yaw motion. So yaw motion is generated with the help of the rudder. Then we have seen pitch motion. So pitch motion is controlled by the elevators which are placed at the horizontal stabilizer. Then we have seen the roll motion, with the rolling which is performed with the help of ailerons. So when one aileron is moving down, the other one will move up and it will create the roll motion. So we have discussed this with briefly. Then we have seen variety of mission profiles of aircrafts based on their applications. So 5 mission profiles and different flight segments we have seen for variety of aircrafts based on their application. So we have discussed a complete idea about the basics of any flight for any aircraft. So we have covered a variety of topics in this course. So the references for today's class are present here, and thank you for attending this course. Thank you.